Introduction to the LCM of two monomials. LCM stands for least common multiple. Multiples. For example, the multiples of 2 would be 2, 4, 6, 8, 10, 2 is 2 times 1. 4 is 2 times 2. 6 is 2 times 3. 8 is 2 times 4. 10 is 2 times 5. So 2, 4, 6, 8, 10. They're all multiples of 2. All right. What if I wanted multiples of 3? It'd be 3, 6, 9, 12, 15, because 3 is 3 times 1, 6 is 3 times 2, 9 is 3 times 3, 12 is 3 times 4, 15 is 3 times 5. Now, if I asked you for the least common multiple between 2 and 3, the answer would be 6. The least common multiple. That means least means the smallest. Common means the one they have in common. And multiple, would be comparing the multiples. So the smallest multiple of 2 would be 2, and the smallest multiple of 3 would be 3. Then the next one is 4. And then 6, and that's the next one for 3 also. So right there, the 6 is a number that is common to both. It is a common multiple of both 2 and 3, and it is the least. Now, I didn't go further on the red, but I could have gone further. I could have gone to 2 times 6, which would be 12. Now, 12 would be another common multiple, but it's not the least. 2 goes into 12 6 times, 3 goes into 12 4 times, which makes 12 a common multiple of 2 and 3, but it's not the least. 6 is. So, I kind of look at this, it's kind of like getting a common denominator, like if you had one fraction that was like 1/2 and you were going to add that to another fraction that was 2/3, in order to add the fractions, you'd have to have a common denominator. But really what you're getting is a common multiple of the denominators, which in this case is 6. So, continue with the fraction, you'd have to multiply top and bottom here by 3 and top and bottom here by 2. This would be 3/6 plus 4/6, which would end up being 7/6. That's something you do when you're adding fractions. You have to get common denominators. But the common denominator is really a least common multiple. And so they just take this a little further, and they're using variables now. So, we're extending it from basic math to algebra. So let me erase all this and bring in our two factors here, or I'm saying our two monomials. We've got a 10n and we've got an 8n squared. So what I do is I start with the 10 and the 8, and I'm like, okay, multiples of 10 are 10, 20, 30, 40. Multiples of 8 are 8, 16, 8 times 3 is 24, 8 times 4 is 32, 8 times 5 is 40. Right there, I found it. The least common multiple between those two would be 40. So I know for the for the coefficient in front, it's going to be a 40. But then I have to look at the n and the n squared. Now n is just n, but n squared is n times n. The variable with the most letters actually ends up being your least common multiple, because if I took this n over here and multiplied it times an n, I'd have an n times n, which matches this n times n. So that makes n squared the least common multiple of the variables. So my answer would be 40n squared. And then I just look at it like, okay, 10 divides into 40 4 times, and n goes into n squared n times. And then 8 goes into 45 times, and n squared goes into itself once. So 40n squared would be the least common multiple. So if I did take it one step further, let's say you were adding fractions. Maybe I gave you 3 over a 10n plus 5 over an 8n squared. You can't add these fractions together until they have the same denominator. So for the first fraction, if I'm trying to get a 40n squared, I'd have to multiply the top by a 4 and an n. So I got to do the same thing up top. I meant to say bottom. I'd have to multiply the bottom by a 4 and an n so that this thing here is a 40n squared. All right? But then my numerator would end up being a 12n. And then over on this one, I've got the n squared. What I don't have is the 40, so I'd have to multiply 8 times 5 and 20 times 5. So now this denominator is a 40n squared, and the numerator is a 25. And now I can actually add the fractions. The denominator would stay the same, 40n squared, and then unfortunately my numerator, you would simply have to write it as 12n plus 25, because those two guys are not like terms. It's not pretty, but that's my answer. That's how you would use least common multiples in this situation. But all they asked for was what would be the least common multiple. So my answer is 40n squared. If they took it a step further, maybe in a future problem, you'd be doing something like this. Hope that explains that.